bit more stable.
I already did. Okay, so there's certain things that we like to take the square root of. So, for instance, if I ask you, what's the square root of 4? Right, the answer there would be 2, because we're asking what number times itself is 4. We can rewrite the square root of 4 as 2. Notice when we give that answer, it's no longer underneath the square root. It comes outside of the square root. Also, if I ask you the square root of 25, right, what number times itself is 25? That would be 5. And if I ask you for the square root of 49, 7. So we've listed this list before, our list of perfect squares. These are the things that I can take a square root of very easily. So again, this is my list of perfect squares. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. 13 times 13. 14 times 14. 15 times 15. 16 times 16. Right, that's as far as I have memorized. Is to go through 2, 5, 6. These are all the things, if they were under a radical, that works out to be a very nice number for us. Now the thing is, sometimes it asks me to take the square root of other things that are not as nice. So for instance, if I ask to find the square root of 12, okay, what number times itself is 12? It's an ugly, ugly decimal number is the answer. Okay, if you put this in your calculator, if you put in the square root of 12, what will it give you? It'll give you an estimated number answer. 3.464101615. And this number continues forever. Right? It's an irrational number. It means it's a number whose decimal never stops. And it never repeats itself. That just continues forever in a random pattern.
That is crazy. So it's technically not, there's technically not a square root of 12?
There is. It's 3.464101615, blah, blah, blah. If I multiply this number by itself, you get 12. Okay, but we don't want to list out this really long irrational number. Right? That's not the way we want to write it. So, what we're going to do today is we're going to learn how to simplify a radical and leave it in radical form. So we did a little bit of this earlier, but we never simplified it.
Yeah, ain't like when you divide what number will go into 12, you divide it, and then like those numbers go outside the radical.
Yes. Yes. So again, we may have done some of this earlier. I don't remember what I have shown you or haven't shown you. But what we want to do, if we're going to simplify this, is we want to think about our list of perfect squares. So again, that's 1, 4, 9, 16, 25, 36, 49. And again, that list continues on. Can I rewrite 12 as one of these numbers times any other number? So here's the way I do it. I pick the number that is right beneath 12 that's in this list. So that would be 9. So can I write 12 as 9 times a number that's a whole number? No. Can I write it as 4 times a whole number?
Yes.
We can. 12 is 4 times 3. So here's how we're going to do this. We're going to rewrite the square root of 12 as the square root of 4 times 3. Now the reason we do this is because we know what the square root of 4 is. So what number times itself is 4? That is 2. So because the square root of 4 is 2, we can take 2 outside the radical, because the square root of 4 is 2. And then what's left underneath the radical?
3.
There's still a 3 left underneath the radical. So we can rewrite the square root of 12 as 2 radical 3.
And you can only use numbers that are square.
You need to pick a number that's a perfect square to go underneath the radical.
Well, it's going to be a perfect square because you're picking from the list up.
Correct.
So
Correct.
you don't ever know it. Wait, so like, how would you put that back into radical 12?
If you wanted to move the 2 back underneath the radical,
Like, how would you go from that state back to radical 12?
this is radical 12. This is radical 12 and this is radical 12. Like, put this in your calculator. Put 2 radical 3 in your calculator. So hit the number 2, then hit the square root of 3.
Oh, it's the same thing.
It's just the simplified radical form. Just like how 3/6 is the same thing as 1/2. This is the way we write it because it's simplified.
Okay.
So the way we would write this would be 2 radical 3 because that's simplified radical form. Pick a number for me.
24.
So let's find the square root of 24. But we want it as a radical. We want it in radical form.
So you can do.
So we're going to simplify the radical form. So think about our list of perfect squares. 1, 4, 9, 16, 25. Okay, I've gone past 24 now. So can I write 24 as 16 times a whole number? Can I write it as 9 times a whole number? Can I write it as 4 times a whole number? 4 times 6. So we're going to rewrite the square root of 24 as the square root of 4 times 6.
Will both simplify? Both numbers or just the first one?
Now what is the square root of 4?
2.
We picked 4 because it's a very easy number to take the square root of. So the 4 comes outside the radical as a 2, and we're left with radical 6 underneath the radical. And 6 does not simplify. Right, you could test them. None of these will work with 6. Here, this one asks me, what's an equivalent expression for the square root of 63? So I am wanting to simplify radical 63. So I'm going to start by listing my perfect squares. 1, 4, 9, 16, 25, 36, 49, 64. So now I always start with the number that is right beneath 63. So in that case, that would be 49. Can I write 63 as 49 times something?
No.
Can I write it as 36 times something? No. 25 times a number? No. 16 times a number?
I don't think so.
No. 9 times a number?
Oh.
So we can rewrite 63 as
9 times 7.
it's 9 times 7.
And then 3 radical 7.
And so we can take the square root of 9 that comes out of the radical as a 3, and radical 7 is stuck underneath the radical. Okay, now ask for another one. What if I ask you for the square root of 44? So I'd start with 36. Can I write this as 36 times a number? 25 times a number? 16 times a number.
Wait,
16, 32, 48. Doesn't work.
no.
Can I write it as 9 times a number?
No.
No, 4 times a number.
Yeah.
It's 4 times 11.
That'd be 2.
And so the square root of 4 comes outside the radical as a 2, and the square root of 11 is stuck inside the radical.
Two of them, like, for example, if that was like 3, 6, or whatever. I know that equals 18, but can you have 2?
Can you have 2 numbers that will come out of the radical?
Yeah.
If you don't pick the best factor the first time, you can. So let me give you an example. Okay, so if I ask you what's the square root of 32, so I'm showing you a process. Like if you use my process, you only have to take one number out here. But let's say you didn't use my process and you said, hey, I can write 32 as,
16 times 2.
you could, but say you wrote it as 4 times 8.
Be 2, probably.
So the square root of 4 is 2, and you're left with a radical 8. But if you do it this way, you're going to have to check again. Can I write 8 as a perfect square times a number? You can. You could write it as 4 times 2. So this 2 is out front, and then 8 is 4 times 2. Right? Now the square root of 4 will come outside the radical as a 2. There was already a 2 out there, so it's 2 times 2. Multiply them. 2 times 2, and then underneath the radical is a radical 2, and then 2 times 2 is 4 radical 2. Now you notice how you had to do multiple steps there. Now why was that? That's because you didn't pick the biggest perfect square first. So if I did the way I taught you to, the number right beneath 32 is 25. Can I write 32 as 25 times a number? No. 16 times a number?
Yeah.
Yes. 32 is 16 times 4. And what is the square root of 16? 4. What number times itself is 16? 4. I wrote the wrong thing.
Yeah, I was about to say, yeah.
16 times 2. That's what should have been underneath there. Not 16 times 4. The square root of 16 is 4, and we're left with a 2 still underneath the radical. My fault. So before we can do this problem, I want us to think about variables with exponents. So like, what is the square root of x to the second?
X.
It is x to the first, because what number times itself is x squared? That's x times x. Okay, what's the square root of x to the 10th? What number times itself is x to the 10th?
X to the 10th. X to the second.
Radical.
2 and 5. What should be X?
X to the 9.
5 times 5 is 25.
It is not, but yes, but we're not multiplying 5 times 5. We're multiplying x to the 5th times x to the 5th. What do you do when you multiply powers with the same base? You keep the base the same and you add the exponents. So x to the 5th times x to the 5th is x to the 10th.
No.
What's the square root of x to the 6th?
X to the 3rd.
It is x to the 3rd. X to the 3rd, you divide by 2, because if I multiply it by itself as an exponent, think about it like this, because
Always doing that something different.
so let me show you very quickly. Here's how it really works. The square root of 16.
X.
What is the square root of 16?
4.
4. The way it really works is you can rewrite 16 as 4 squared. And so what's the square root of 4 squared? Those cancel and you're left with just 4. Right? That's what happens. So that's why if I take the square root of x squared, it's x.
So why is it half of each one?
Because you're adding the exponents.
Adding the exponent.
When you multiply powers, x to the 5th times x to the 5th is x to the 10th. When you add something to itself, you're doubling it. So when I multiply powers and they're the exact same power, I double it. Like what's x to the 3rd times x to the 3rd?
X to the 6.
It doubles. So if I go the opposite way, what times itself is x to the 6th? You're halving it.
Okay, so why isn't 3 have a square beside it? How does x to the 6, radical x to the 6 equal x to the 3rd?
Because
How does
x to the 6th can be written as x to the 3rd squared. Because it's x to the 3rd times x to the 3rd. And so the radical and the square cancel. And it leaves me with x to the 3rd. All you have to know is half your power. We like to take the square root of an even power. So look at what this is here. This is x to the 9th. Well, what number times itself is x to the 9th? No, it's not a.
It's 4 or 5.
It's between 4 and 5. All right, it'd be 9 halves. So the way we're going to have to work this out is a little bit different. So let's work this problem now. Look at this one. I've got the square root of 63 x to the 9th. So on this problem, the square root of 63 x to the 9th. We're going to take the square root of 63 just like we did before. So we could write this. 63 is 9 times 7. X to the 9th is still here. What's the square root of 9? 3. So 3 comes out front. And I'm left with the square root of 7 x to the 9th.
3x to the 3rd.
No. You're treating the 9 as a regular 9. You're not treating it as an exponent. So now the x to the 9th, we like our exponents to be even. So what we're going to do is rewrite x to the 9th as x to the 8th times x.
Why? Oh, you like to be even? Why?
Because we like it to be even.
Why?
Because we can just half it.
Oh, okay.
Right? What times itself is x to the 8th?
X to the 4th.
X to the 4th times x to the 4th. So I can bring x to the 8th out as x to the 4th.
Exponents when we multiply. That's why I was confused.
And now what's left underneath the radical? The 7 is left, and the x to the 1st is left. Neither one of these will break down again. So this is 3x to the 4th.
So when you half it and bring it outside, you just half it and bring the whole thing outside.
Correct. Just like why so if we had this one, the square root of 25x to the 3rd.
5 times 5.
So the square root of 25 is 5. Well, 5. And then what's the square root of x to the 3rd?
X squared plus x.
So we could rewrite x to the 3rd as x squared times x.
Can you just be x to the 1st on the other side?
And so this x squared will come out of the radical as x to the 1st. And then what's left inside the radical?
Just X.
The x. So that's
Wait,
5x.
Wouldn't the 5 not come out too?
It did come out.
Stay in?
No,
Why not?
because 25 was a perfect square. Did you not tell me the square root of 25 is,
5.
and it comes out of the radical?
Oh, yeah.
Right? That's what people confuse the most on this, is they'll take the square root of a number and then leave it inside the radical. So I'm trying to get you out of that habit right now.
Make mine be X
Hmm?
right there is when they go.
This?
5x2.
No.
No. X to the second square is X to the first. Because you add the exponent.
We don't have anything called 5x2, first of all.
Or 5x to the second, but
Okay.
wouldn't I just make 5x second?
No. Because this x is underneath the radical. You can't do multiplication with something underneath the radical and something outside the radical. Those don't combine. All right, what did we get here on this one?
I think, okay, so, I need a little bit more time because,
Okay, I'm just gonna say what I did in my head. 10x to the 8th radical 2x to the 8th. Is that right?
No.
No. I
Okay.
don't think so.
10x to the 8th radical.
Why are y'all leaving a 2 underneath the radical? How did you bring a 2 outside the radical and leave a 2 inside the radical? Here's what y'all are doing. This is the same mistake I just told y'all were making. You're taking something like this. You're saying the square root of 25. You're saying that's 5 times 5.
Yeah.
So you're saying the square root of 25 is 5 radical 5.
It's just radical.
I got it.
It's not just radical 5. It's just 5.
Alright.
When you take the square root of a perfect square, the radical goes away.
So then it'd just be 10x to the 8th and then radical x to the 8th.
I got 10
No.
to the 4th radical x.
10x to the, it's not the 4th.
Then what would it be? Because if you take the, okay, so like
10x to the 8th radical x.
10,
the 8th.
because when we take the square root of an exponent, we're really just cutting it in half. Remember, what times itself is x to the 16th? X to the 8th times x to the 8th. That's what a square root is asking. You took the square root of 16,
Yeah.
but it's not a regular number, it's an exponent. So again, this should be 5 times the square root of 4 is 2, so 2 comes outside the radical. And then x to the 17th, we could write that as x to the 16th times x. And now I know how to take x to the 16th out of the radical. So 5 times 2 is 10. The square root of x to the 16th is x to the 8th. And you're left with the square root of x.
2x squared radical 10.
2x squared radical 10. What do you guys think?
I think he's horribly wrong, terribly wrong. I think it's 24.
That is correct. So 40, is 40 a perfect square? No. But we could write 40 as 4 times 10. Right?
Yeah.
The square root of x to the 4th
It's 2.
is x to the 2nd,
Yeah.
or x squared. And now we can take the square root of 4 out of the radical. The square root of 4 is 2x squared, and then 10 is still underneath the radical.
Does it matter when you put the x out there?
No,
Okay. I did it after.
that's fine. Doesn't matter. I'm just showing, as long as all of your steps are valid, you're good to go. All right, do we have our answer? So is a
Okay, so I put 1x squared radical 11
This close.
Really?
It's close.
How close?
Well, so 11, is 11 a perfect square?
No,
Can I rewrite 11 as a perfect square times something else?
no.
No.
Well,
Besides 1, which is,
useless.
right, it doesn't really help. So 11, the square root of 11 will stay underneath the radical. Doesn't come out. Now what about x to the 5th?
X to the 4th times x.
We could write that it's x to the 4th times x. And now what is the square root of x to the 4th? X to the 2nd. And so then what's left underneath the radical? An 11 and an x.
If I would just put the x.
You'd have been right.
Last
X squared radical 11x. All right, let's look at this. This tells me to find the product. So all a product is an answer to a multiplication problem. And so you see they have the dot there telling us to multiply. So here's how I think the easiest way to do it. Is everyone ready? So you see how I have numbers outside the radical? Multiply those together. 3 times 2 is 6. Then I have a square root. You see how I have numbers underneath the radical? Multiply those together.
Wait, how would you just, you wouldn't do the radical like that, so you just, I would say by like combining them.
We're going to multiply them. And they're going to go underneath the radical. So 5 times 15 is 75. X times x to the 3rd. It's x to the 4th. Remember, we have to add our exponents. There's an understood x to the 1st there. All right, is everybody good with that step?
Yes, sir.
Now take what's underneath the radical and see if you can simplify it. So the square root of 75, is that a perfect square? No. Can I write it as a perfect square times a number?
25 times 3.
25 times 3. So I've got a 6 out front. I'm going to rewrite this as 25 times 3. What about x to the 4th?
X stays the same. Or no, wait, you have to.
I can take the square root of x to the 4th. That will come outside the radical as x to the 2nd.
So 6x.
So I've got 6x squared. And then times the square root of 25 times 3. What is the square root of 25?
5.
So that's going to come out front as a 5. So now I have 5 times 6 times x squared times the square root of 3 is stuck underneath the radical. 5 times 6 is 30. 30x squared radical 3.